Students, in order to do well, you need to develop your critical thinking skills, which is visualization, logical reasoning, and pattern spotting. Not only that, we need to understand more concepts and apply certain simple strategies so that you can solve the question with speed and accuracy. So get ready to put on your thinking cap and be creative today. Let's look at day 1 of the Accelerate Bootcamp. Well, since it is only day 1, the questions are not that difficult yet. Okay, so we'll slowly warm up until we reach a crescendo at day 3, and finally we go all the way to day 4, which is going to get more difficult as we go along. Okay, so let's look at question 1. This question should be pretty straightforward. Why not I give you 1 minute and you see if you can give me an answer. Come everyone, type your answer in the chat, please. Okay, time's up, students. Now imagine you have 4 packets of cookies. Okay, 1, 2, 3, and 4. Okay, now they say that at least each packet has to have at least 2 cookies. So let's say you put 2 cookies in every packet, right? But however, the question also says that every 3 packets must have 8 cookies. That means if you select any 3, there must be at least 8 cookies. So students, if I select these 3, do I have 8? Unfortunately not. So what must we do? We must make sure that we increase the number of cookies. So why don't we put 3 and 3? Now you say, okay, very good. I have 8. And I have 8. Is this the at least how many cookies must Johnny have? They are asking you for the least number of cookies. So can I say that there's 10 cookies? No. You know why? Because there's still a way for me to select 3 packets with only 7 cookies. So can it be 2, 3, 3, 2? I don't think so. You cannot have any 3 packets that have less than 8. So we have no choice. We have to increase the number of cookies again. Now you ask yourself, is there any way that you can select 3 packets with less than 8? This time round, if you select any 3 packets, you will definitely have 8 cookies at least. Therefore, we will have to say that the least number of cookies that Johnny has is 11. Okay, students? Anyone have questions about this? All right. So, play around with the numbers. Make sure that you satisfy the rules, the conditions given in the question. Okay, well done, Brian and Elias. I saw you all right 11. The rest of you, a lot of you gave me the answer 10. Okay, let's try question number 2. So students, this is a logical question, right? If Kenny lies on Monday, Tuesday, and Wednesday, and he tells the truth on other days, but Lenny lies on Thursday, Friday, and Saturday, and tells the truth on other days. So today, Kenny tells Lenny that yesterday I was lying. And then Lenny says, so was I. Which day of the week is today? Let me give you 2 minutes to think about it. Tell me, which day of the week is today? Type your answer in the chat, okay? So, Isabella, I have drawn a table here. Okay, and in this table, we are going to take note of which days Kenny is lying and which days Lenny is lying. So, on Monday, Tuesday, and Wednesday, Kenny is lying. Lie, lie, lie. Or let's just say false, false, false. And on the other days, he's telling the truth. As for Lenny, he tells the truth on every day except for Thursday, Friday, Saturday. So truth every day except for Thursday, Friday, Saturday. Now, let's read the statement. Kenny tells Lenny, yesterday I was lying. And then Lenny replied, so was I. Okay, Isabella. Why not we just pick a day? Okay, let's just say that it is Tuesday right now. Is it possible for Kenny to tell Lenny, okay, let's say today is Tuesday. So if I'm Kenny and I say, yesterday I was lying, is it possible for Lenny to say, so was I?
No, true.
No, because you see, today Lenny is telling the truth. And if he tells, so was I yesterday, it's false what? Yesterday he was not lying what? So Lenny, it's impossible for Lenny to say, so was I.
I have a question.
So which day is it possible for Lenny to say, so was I?
Like
So,
Sunday?
Sunday, ah. Okay, yep. So on Sunday, Lenny tells, what did I, okay. So on Sunday, Lenny tells Kenny that he was lying, which is true, by the way, it is true. But is it possible for Kenny to tell Lenny, yesterday I was lying?
No.
So which day is it possible? Can we look for another day?
Wait, when Lenny says so was I, can he lie?
Can. Lenny can lie also if
Thursday.
Thursday. Okay, so look at Thursday. Kenny is telling the truth. He said yesterday I was lying. Then Lenny is replying that so was I. But actually it is a lie. Yesterday he was not telling the truth. So which day is possible?
Thursday?
Correct. Very good. So does this make sense, Isabella?
Yes.
All right. Well done. So the answer is Thursday. Good job. So students, look, we have tested it out and realized that this is only possible on a Thursday. So we write down Thursday. Okay? Well done. So many of you gave me the correct answer. Good job, students. Anyone have any questions about this? Aiden, question.
But if Lenny says that she liked it yesterday, but if you look at the table, she said the truth yesterday.
She say what today?
He said the truth yesterday.
That's why he's lying, what? He said, so was I. He said, actually, today he's telling a lie. Thursday, right? Lenny is telling a lie. So he's lying that he lied yesterday.
Oh, oh my God.
Yeah. Okay, very good. Yeah. So let's try question number 3. There are 55 seats on the bus, and one commuter boarded at the first stop, two people boarded at the second stop, three people boarded at the third stop. So at every stop, more and more people are boarding the bus. So at which stop will all the seats be occupied if there are 55 seats on the bus? Come everyone, try this question and type your answer in the chat, please. Very good. Everyone got it correct. Good job, students. Let's take a look. At the first stop, one person boarded. At the second stop, two people boarded. At the third stop, three people boarded. So you just need to keep on adding 1, 2, 3, 4, 5 until you get the answer 55. So let's try to add until 10. Will we get 55? Well, yes, you will. Okay, but how do we get 55? We must use the Gauss summation. So let's write it down. How do you use Gauss summation, students? Students, you have to take the first number plus the last number multiplied by how many numbers are there, and you have to divide it by 2. So we are essentially pairing up the numbers. Okay, 1 plus 10 is 11, 2 plus 9 is 11, 3 plus 8 is 11, right? So why are we dividing by 2? Because we are finding how many pairs of 11 there are. How many pairs of 11 there are, okay? So let's do our workings. First number plus the last number multiplied by how many numbers are there divided by 2. So you notice that you have 5 pairs of 11, which will give us 55. Very good. So we have managed to get 55. Therefore, how many stops are there? There are 10 stops. There you go. Yes, question from Zain.
Then can we just use the Gauss summation to work back the answer?
Yes, if you want to use Gauss summation to work back the answer, wait, let me see. You use the first and the last. So you are trying to guess what is the last number, right?
Yeah.
Yes, you can do that. Very good, Zain. Yes, Aiden?
The answer is not telling you how many stops is there. It's telling you like which stop if all the seats will get occupied.
At the 10th stop, right?
Mm.
Yes. Okay, so how do you guess if you work backwards? Because you see, let's say you want to use Gauss summation to guess how many stops there are. So what you're doing is you're trying to find what is n. What is n, right? And you already know that the last number equals to n. So what we can do is we can write down an equation actually. You can say that the first number plus the last number multiplied by how many numbers are there divided by 2 equals to 55. Okay, so now we're going to get rid of these 2. Let's multiply by 2. So if you multiply by 2, this will be gone. The denominator will be gone. So you just multiply this by 2. You end up with n times n plus 1 equals to 110. So you ask yourself, which two consecutive numbers can multiply to give you 110? Well, we know that 10 times 11 equals to 110, right? That means n should be equal to 10. So there are 10 stops. Yes, Isaiah, question.
How long is the session?
1.5 hours until 10:30.
If we finish before that, we can end the class earlier, right?
No, I'll give you extra questions. Why? You're not going to play our games, is it?
I can't. Need to work.
Yes, very good. Okay, so let's try. So this is how you guess. This is how you determine what is the value of n. Okay, students? So let's try question number 4. So this is a combinatorics question. They will ask you how many different ways are there for this frog to jump from lily pad A and go back to lily pad A again. Okay? So can I give you 2 minutes? Let's see how many ways you can find and type your answer in the chat. Your time starts now. All right, students, can I have a show of hands? How many of you manually counted the path that the frog took? How many of you did that? Ah, yes, and it's taking a lot of time, right? Well, okay, you can put down your hands. Let me ask YN. Hi, YN. Okay, YN, can you tell me what is one of the paths that is possible for the frog to take?
A, B, A, B.
A, B, A, B. Okay, hold on.
No, no, no. It first jumps to B, then it jumps to A, then it jumps to D, then it jumps. Oh wait, or you just want like maybe like that.
You must jump at least 4 times. You must jump 4 times exactly.
Mm-hmm.
Okay, because
So
on the fourth time that you jump, after you jump for the fourth time, you must end up on lily pad A again, right?
Then B.
No, you start from A. He's on A right now. So A, B. Okay, so you jump one time, then you jump two times, then you jump three times, and you jump four times. This possible?
Yeah.
Yes, it is possible. Okay, yeah, sure, of course. Okay, so let's write it down first. Okay, let's draw some lines, and we are going to fill it up with the different possible paths that the frog can take. Okay, so let's say it is possible for him to jump A, B, A, B, back to A again. Yes, it is possible. Give me one more.
A, then C, then A, then C.
Yes, A, C, A, C, A. Okay, give me another pattern. Another pattern.
A, B, C, B. B,
A,
A.
B, C, B, A. Yes, you can do that. Okay, very good. Wait, before you move to this pattern, why not we stick to this pattern first? We just change instead of A, B, A, B, A, what if we just replace this with a C? Then that will give us another pattern already, right? Okay, so let's try this. A, C, A, B, A. And we can also try to just replace the C with a B. We can try to replace it with a B. Then we'll come up with something new. A, B, A, C, A. Okay, so we have already calculated all the different paths where he always goes back to A here. You notice he always goes back to A here. Okay, so now that we have written down all the paths where he always goes back to A in the middle, why not we think of another one where he does not go back to A? Can you tell me one?
A, B, C, B, A.
A, B, C, B, A. Yes, that works. That works. What about another one?
A, C, B, C, A.
Yes, A, C, B, C, A. Is there any other path? Is there anything else?
I think so.
No. So how many ways are there? There are 6 ways. Correct, YN?
Yeah.
Very good. You have any questions about this? All right. Thank you, YN. Kyla has a question. Yes, Kyla.
There's another way to do it.
Yes, I was about to touch on the other way to do this, but why not you tell me what is the other way to do this?
The left side A, then just draw like a Pac-Man, then besides put B and C.
Okay. Uh-huh. Oh, start with A, then do this, then put B and C.
Yeah.
Very good. So you're using a
Then just into B.
so you're basically
Yeah.
you're using branching method, right?
Yeah.
Very good. Thank you, Kyla. Students, there's another way to do this, okay? We start from A, then he has two choices, B or C. So when he's on B, he will have another two choices. He can either go back to A or he can go to C. If he's on C, he can either go to A or go to B. And then you continue branching. All right, students, every time you end up on a lily pad, you will be able to have two more options, except for the last jump. On the last jump, you only can go back to A. Yes, Aiden.
At first, when I wrote 6, I thought like it's 4 lily pads instead of 4 jumps. Then I do like,
Oh
and
no.
I also didn't read that A. So I just do A, B, C, A, then A, C, B, A, then C, A, B, C, then yeah.
Oh my gosh, you're lucky that you got the correct
And
answer.
I thought, I still thought it was 4 lily pads when we were going through the answer. So I just do A, B, C, A, and A, C, B, A. Then
Okay, but now you know what the question really means, right?
yeah.
All right. Yes, Zane.
I don't know if it works. Does it work if you just do like a fourth jump and 3 lily pad divided by 2? Or is it just lucky?
I think you're just lucky. Okay, that's not the correct way to do it. Now, students, there is another way to do it, which is to consider two different scenarios. So there are 4 jumps, right? 1, 2, 3, 4. So I'm drawing 4 lines here. Why? These 4 lines represent how many options he has. Okay, it represents how many options he has for each jump. So let's just say that this is case 1. This is the first case. And we have 2 different cases to consider here. This is case number 2. So students, let's say we consider the case where, let's consider the case where he always goes back to A. He always goes back to A. And let's consider the case where he does not go back to A. 2 cases. All right. So in case number 1, you start from A, so you have 2 options. You can either go to B or C. So I'm just going to multiply by 2 here. I'm just going to write down 2 here because you have 2 options. Then you only have 1 option because you are forced to go back to A. So I'm going to write that you only have 1 choice. You have to go back to A. So from A, you have 2 choices again. You can either go to B or C. And after that, you only have 1 choice, which is to go back to A, right? So there will be 4 ways for you to do this. What about scenario number 2? You start from A, you have 2 choices. So after jumping to, okay, let's say you start from A, you have 2 choices, B or C, right? So let's say you chose B. But if you do not want to go back to A, you can only go to C, so you have only 1 choice. Then after that, you cannot, if you're on C right now, you cannot go back to A. You must go to B. So you only have 1 choice. Why? If you go back to A, then you cannot end up at A. And finally, if you go to B, then you have only 1 choice, go back to A. So there's only 2 ways for you to do that. And we have written it down here already. Can you see that there are 4 ways to do this? This is scenario number 1. There are 4 ways to do this. And there are 2 ways to do this when you do not go back to A in the middle. And when you add them up, you will still get 6. All right, students. So students, if you know how to use scenario 1 and scenario 2, then you do not need to write down all the different paths. And I would believe that it will take lesser time. Okay, students, so next time, try to consider different scenarios. You can just multiply the numbers together. You do not really need to write down every single path. Anyone have any questions about this? All right. So let's try the next question. Wait, hold on. Question 5. So, students, this is a working backwards question. Instead of dividing by 4, Alice multiplies. Instead of adding 28, she subtracted 28. In the end, she got 36. So what should the number be? Come, students, can I give you 2 minutes to work this out? Your time starts now. Now, students, why did I draw 3 circles here? Because this allows me to work backwards. The circle represents the original number. Okay, we don't know what is the original number yet. Okay, but what we know is that Alice multiplied it by 4 and she also subtracted 28 from the number. In the end, she managed to get 36. So all you need to do to find the original number is we have to work backwards. So we just go backwards. Whenever you work backwards, you need to do the opposite. So instead of minus 28, you're going to do the opposite, which is plus 28. And instead of times 4, you are going to divide by 4. Then you'll be able to find your original number, right? So 36 plus 28, divide by 4. And you know that the original number is 16. So this question, what is the question asking for? They say, what was this number? So are they asking you what is the original number? Or are they asking you what should the correct answer be? Well, in this case, they are asking you what was the original number. So the answer is 16. However, even if the question asks you what should the correct answer be? What should the correct answer be? You can find it. You can find it because now you already know the original number. Then dividing by, okay, so you're supposed to divide it by 4, right? So you're going to divide it by 4. And then you're going to add 28. You can still find what is supposed to be the correct answer. Okay? But in this case, the question is asking what was the number. So whenever they say the word instead, right? Instead, it is just a distraction. It is just a distraction. So our final answer is 16. 16 was the number. The number was 16. All right, very good. A lot of you gave me the correct answer, 16. Well done. So students, this technique is very useful, working backwards. It can be used in complicated problem sums. Okay, and you can even draw more circles like that. If there are more steps, you can draw more circles, no problem. And it can be used to simplify complicated problem sums, which we will see throughout this bootcamp. Okay, in the next few days, we will come across problems which requires you to work backwards. So we will come across this technique again. All right, let's try question number 6. You are given all the multiplications here, and you're supposed to figure out what is a possible value of A, B, C, and D. So students, I don't need you to tell me all the values. I just need you to give me one possible value of A, B, C, and D. Just give me 4 numbers that are possible, and then I will know whether you got it correct. So everyone, I give you 2 minutes. Type your answer in the chat. Your time starts now. Just give me one possible value where A, B, C, and D will work. All right, everyone. So this question has got to do with factors. What is a factor? So when I ask you what is the factors, what are the factors of 10? You just need to tell me 10 equals to 1 times 10, 2 times 5. So you can tell me that the factors of 10 are 1, 2, 5, and 10. If I ask you what are the factors of 6, you tell me 1 times 6, 2 times 3. The factors of 6 are 1, 2, 3, and 6. So these are called factors. right? Now, let's find out what are the factors of, okay, let's say A and B gives you 18. So let's find out what are the factors of 18. That's it. 1, 2, 3, 6, 9, 18. So these are the factors of 18. Now let's look at C and D. What are the factors of 48? So let's write it down. 48. There you go. These are the factors of 48, right? So now that we know the factors, we can make a list of all the possible values of A and B, C and D. Let's start with A and B, okay? Okay, this is A, B, C, D. Start with A. Write down all the factors of 18. 1, 2, 3, 6, 9, 18. Now, if A equals to 1, if A equals to 1, B must be 18. Because 1 times 18 is 18. Okay? If A equals to 2, B must be 9. If A equals to 3, B must be 6. If A is 6, B must be 3. If A is 9, B must be 2. If A is 18, B must be 1. So it is basically the opposite, the reverse. B is the reverse of all the factors of A. So you can see what? 1 times 18 is 18. 2 times 9 is 18. This is 18, this is 18, 18, 18. Right? So these are all the possible values of A and B first. What about the possible values of C and D? So for C, we are going to write down all the factors of 48. So we're going to write down 1, 2, 3, 4, 6, 8, 12, 16, 24. Uh-oh, not enough space. One moment. Okay, let me just move this over there. Make more space. Okay, that's better. And 48. Okay. And what is D? D is the opposite of C. So we write down 48, 24, 16, 12, 8, 6, 4, 3, 8, 28, 48, 16, 12, 8, 6, 4, 3, 2, 1. 4, 3, 2, 1. There you go. Now you ask yourself, which are acceptable and which ones will not work. Okay? So now we need to observe. B times D is equal to 36. If B times D is 36, can we do this? B times D, 36. I don't think so. So students, we have to eliminate those that will not work as well, right? So is it possible for D to be 48? No, it is not. Is it possible for D to be 24? Because you need to have D times C, D times B to give you 36. So is it possible to get 36 when you have 24? I don't think so. It is not possible. So 16 is also not possible. But what about 12? Yes, 12 is possible because you can take 12 times 3 to give you 36. Okay, so 12 is possible. What about 8? Nope. What about 6? Yes. 6 times 6 is 36. 4, yes. 4 times 9 is 36. 3 is possible. 2 is possible. 1 is also possible. What about C? If you look at C, they say that A times C equals to 24, right? A times C is 24. So is it possible for A to be 48? Is it possible for C to be 48? No. But is it possible to be 24? Yes. Is it possible for C to be 16? No. You can't even get 24. Is it possible to be 12? Yes. Is it possible to be 8? Yes. 6? Yes. 4? Yes. 3? Yes. 2 and 1 also yes. So students, is this the final answer? Isaiah, yes. You have a question.
I got it first try. Actually, when I started doing the method, I actually just decided find out 36 was first, and then I got it.
Okay, but you notice that when I ask you all to give me one possible answer, I'm only asking you to give me one answer, right?
So I use B B as 6 D as 6 just as one possible
Yeah, but actually the question is asking for what? What is the question asking for?
value.
So they're asking you to find all the possible values, not only.
I can actually just find all of them if I wanted.
Yeah, so there must be a systematic approach that we are using. Yes, Zain.
Supposed to answer for the next question.
Sorry?
The next question is how do we show the answer?
Zain, you're asking about which question?
The next question.
Why?
How are we supposed to answer it?
I'm not done with this question. I'm not done with this question, Zain. I'm not done with this question. Okay, students. So far we have all these possibilities, right? So next you need to ask yourself, are these all the possible answers for A, B, C, and D? When we wrote down all the factors of 48, when we wrote down all the factors of 48, we somehow lost we somehow lost the answer, because if you do it like that, do you know that it is no longer possible to get all the 4 possible answers in the same column? So in order to get all the possible answers in the same column, we should do it in another way, because we already know what are the possible values of A and B. We don't have to write down all the factors of 48. Instead of writing down all the factors of 48, we can simply work it out using A and B. So I'm going to remove the factors of 48. Before we start, let's look at the possible value of A and B first. You notice that A times C is 24. So A cannot be 18, because it's not possible for you to get 24 if you use 18 times another whole number, right? A cannot be 9. A cannot be 9 because 9 times something equals to 24. It's not possible. Okay, let's look at B. Okay, if 9 and 18 are not possible, 1 and 2 are also not possible, because you need to pair them up in order to get the correct answer. A times B is 18. A times B is 18. So if A cannot be 9 and if A cannot be 18, you cannot have 2 and 1 for B as well. So B will be affected by your A. Next, we move on to C and D. If you already know that A equals to 1, and you know that A times C equals to 24. So what is your value of C? 24, right? And if you know that B is 18, B is 18, and you know that B times D is 36, that means D must be 2. So we slowly figure out what is C and D depending on the value of A and B. So let's do that. This is much faster. 12, 8, and 4. And finally, 4, 6, and 12. So students, whenever you trace a line down like that, you'll get all the values of A, B, C, D. A, B, C, D. Okay, so there are 4 possible values. It could be 1, 18, 24, and 2, 2, 9, 12, and 14, 2, 9, 12, and 4, 3, 6, 8, 6, or 6, 3, 4, 12. If you have given me any one of these 4 answers, you would have gotten it correct. Okay, students? So you don't actually need the factors of 48 for this question. You only need to find the factors of 18. So these are all the possible values of A, B, C, and D. Yes, Aiden, question.
I didn't use this method. I just instantly predict that A is 2, and I just found out all the other answers.
But the question requires you to find out all the values. You know what I mean? Yeah. All right, very good. So let's take a look at question 7. Now, students, you notice that in this question, they want you to divide it into 2 parts of equal area. Now, if you count how many circles there are, you have 8 circles. So if you have 8 circles, then what is the area of each? Okay, so you have a total 8 circles. So half of it must be 4 circles. So as long as you draw a line and each side of the line adds up to 4 circles, then you are correct, right? So I'm going to label each point A, B, C, D, E, F, G, and H. How many ways are there for you to do so? How many ways are there for you to divide this into 2? If we draw a line from, okay, let's say we draw a line from D to F. Will this work? How many of you say yes? Raise your hand. Will this work? Very good. Yes, it will. You see, you have half of a circle here, half of a circle here. It adds up to 1. So 1, 2, 3, 4. It will definitely work. Okay, so one of the answers will be D to F. What other answers can there be? Can everybody think about it for 1 minute and type what is another possible line that you can draw? Use the alphabets to give me your answer. Come type which alphabets are possible. So students, this is pretty simple. If you were to draw a line through BG, you'll definitely get half, right? So BG is another option. And there's one more, Did anyone spot one more that I have not written down yet? If you know one more, can you type it in? Very good. AH. Well done. Okay, so if you do AH, I know that this looks a little bit complicated. However, observe this area here, students. Look at this tiny little area here. And look at this tiny little area here. They will cancel out each other. They will cancel out each other. And then you will have 4 circles on each side as well. Okay, students? So the answer, one more answer could be AH. So there are 3 possible answers actually. Now, one of you type CE. If you draw a line through CE, will it work? Well, it's very obvious that CE will not work because you only have 1, 2, 3.5 circles. You only have 3.5 circles on top and 4.5 below. Okay, so CE will not work. All right, students, so what is the trick here? Visualization skills are very important. You just need to make sure you count that all the halves of the circle or all the tiny little parts, okay, for example, AH, it can cancel out each other. As long as you have 4 circles on each side, then you are correct. Now let's take a look at question 8. Alice and the Mad Hatter, the rabbit, and the cat live on second, third, fourth, or fifth floors of a 6-story flat. There are some designs on their doors as well. Diamonds, hearts, clubs, and spades. Okay? So these are like playing cards. You see, diamond, this is a diamond, heart, club, and spade. So there are different designs on their doors. And they are living on different levels of the building. Now, the question is giving us some rules to follow. So please read the rules carefully. And you must determine on which floor does the Mad Hatter live and which is the design on his door. So if you think that he lives on level 2 and you think that there's a heart shape on his door, then you can tell me, you can type in the chat 2 of hearts. Okay? So it depends on what you think. You can type your answer in the chat. I give you 2 minutes. Your time starts now. So students, some of you told me that you look at the picture and you came up with your answer. Please don't do that, okay? In mathematics, firstly, we know that in mathematics, diagrams are not drawn to scale. Secondly, how do you know that this picture is not just there to distract you? You must always prove your answer. You must always prove your answer, okay? So let's create a table first. It must be logical. It must make sense. So we have which levels? We have second, third, fourth, and fifth floor. Level 2, level 3, level 4, level 5. They say that Alice lives on the floor which is higher than the Mad Hatter, but lower than the rabbit. So if you have a Mad Hatter, then Alice, and then the rabbit. Now that makes sense. It could be like this, right? This could be the case where the Mad Hatter is on the lower floor. Sorry, Alice live on the floor higher than the Mad Hatter, lower than the rabbit. So Mad Hatter, Alice, rabbit, or it could be Mad Hatter, Alice, rabbit, or it could be Mad Hatter, Alice, rabbit, something like that. As long as we know the sequence. As long as we know the sequence. And we can change it as we go along. We can change it as we go along. So we write down Mad Hatter, Alice, rabbit. Then they say that the cat lives on the 5th floor. Oh, so we already know that the cat is here. Easy, right? They already told us cat is on the 5th floor. Spade's door is 1 floor higher than the clubs. That means the spade must be higher than the clubs. Okay? But 1 floor lower than the heart. 1 floor lower than the heart. That means the spade is 1 floor lower than the heart. The diamonds is the lowest. Ah, diamonds is the lowest. So why not we just move everything one step higher? So we can say diamond is the lowest. Then we can say clubs. And then we can say spades. And finally heart. Right? So students, which floor is the Mad Hatter on? The Mad Hatter is on level 2 with a diamond on his door. Isaiah, yes, question.
I did not use the picture, but I used logic. Actually, like it's literally just a giveaway for the design. Just because if you figure out matters on the lowest floor, you know what's the design. It's just a giveaway.
Not really true because there's a
The design is on the last. No, I say if you read the question and it says diamond store is the lowest. So if you figure out which Manhattan's on the second level,
yes.
which is the design because diamond store is the lowest and the lowest is second floor.
Correct. If you already know Mad Hatter is on the second floor and they already say diamond is on the lowest floor, Mad Hatter must be diamond. Yes, Isabella.
I mean, just now you said it might not be right the drawing, but then when I finish doing this one by logic, and then I look at the drawing, it's exactly the same. So if during I don't know, some kind of exam, this actually comes up and then the drawing, should we refer?
No, do not look at the drawing. You see, even the sequence is different. Or even if you know that this is the Mad Hatter, it could be a heart. Don't look at the drawing, okay? Yes, Zane.
It's wrong just because I do the wrong arrow and then I just got confused.
Do you draw a table?
Yeah, I did your thing.
Oh,
It's not a table.
okay.
I just do arrows to indicate who's who.
So students, please draw a table, okay? Then you can organize your information. This is how you solve logical questions. Yes, Elias?
I more like drew a building.
Oh, you drew a building? Yes, Aiden?
Wait, so is Alice literally the Mad Hatter or they're different people?
Different people, different people. This story is from Alice in Wonderland. It's a book. Yeah, it's a book. Yes, Isaiah?
I did not draw a table. I just did it on my mind.
Can, but just be careful. If the question gets more complicated, you might want to draw your table, okay? Okay, let's take a look at question number 9. Express 18 as a sum of two numbers. So what is the largest product? Students, when they ask for product, that means you must multiply them together. So if you express 18 as a sum of two numbers, there are many ways to express it as a sum of two numbers. 18 equals to 1 plus 17. 2 plus 16. 3 plus 15. So many ways to do it, all the way until 8 plus 10, 9 plus 9. Now, students, they are asking you, after you express it as a sum of its digits, as a sum of two numbers, what is the product of these two numbers? That means they want you to multiply the two numbers together, and they want you to get the largest product. So why not we go ahead and multiply them together? You only get 17 here, right? And as you go along, the numbers get bigger. The answer gets bigger. As you go along, the product gets bigger and bigger. So if you want the largest product, obviously you have to take 9 times 9. Therefore, we can say that the largest product is 9 times 9, which is 81. Okay, so this was quite simple. There you go. Anyone have any questions about this? Okay, now let's try question 10. Which of the following does not belong in this number pattern? Students, so you must try to spot the pattern first, and you must find which number is not supposed to be there. There's only one number that's not supposed to be there. Can you type your answer in the chat, please? Wow, that was fast. Isaiah, I saw your answer already. Zach, Elias, Jaros, very good. All of you getting it correct, huh? Well done, Brian, YN, Isabella, Hanson, Jaros, Zach, Elias, Isaiah. You got it correct. The number that is not supposed to be there is the number 8. The number 8 is the odd one out. It's not supposed to be there because when you look at the pattern is you add 1 and then you multiply by 2. You add 1 and then you're supposed to multiply it by 2. So you're supposed to get 14, not 8. Then you add 1 and you multiply by 2. Can you see? Therefore, the odd one out is 8. All right? Yes, Aiden.
I thought the pattern was like even, odd, even, odd.
Even, odd, even, odd, even, odd. Ah. Okay, so if it's even, odd, let's see what will happen. Even, odd. Okay, let's highlight all the odd numbers first. Okay, then all the even numbers are 6, 8, and 14, and 13. So if you follow even, odd, do you know which number to remove or not?
Not like the correct one, like the exact one.
Yeah, so if you follow even, odd, you have two possible answers that are not supposed to be there. It's either 8 or 14 that's not supposed to be there, right? So that's why, yeah, so that's why,
Because in math, there's only one.
yes, you should only have one correct answer. Well done. Okay, so anyone else has any other patterns? Okay, so let's try question 11. Two circles form a friendly pair if they are touching each other. How many friendly pairs are there? Well, we just have to count. 1, 2, 3. These are all touching each other, right? 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. There are 30. There are 30 friendly pairs. Now, this diagram may be easy for us to count, but what if they give you a diagram with many more circles than this? Are you going to count one by one? No, right? If they give you a pattern which has many more than this, can anyone tell me what method can we use to count the number of pairs? So, students, very good. You can actually count how many. You notice that there's a triangle here, right? So students, if you just count the triangles and you multiply it by 3, you will also be able to get your answer. All right? Very good. Let's talk about question 12. Now, this is the pigeonhole principle. You have 13 pink, 33 green, and 12 red socks. So, at least how many socks do you have to take from your drawer in the dark? In the dark, that means you're not able to choose which color you're taking. you must make sure that you have a matching pair. So students, imagine you're blindfolded, you can't see anything, you know. So it is by luck, right? So students, I give you 2 minutes to think about this. How many socks do you need to take out to make sure that no matter what, you will have a matching pair? Type your answer in the chat, please. Okay, Isaiah, tell me, what is the logic behind this?
So let's say that there are three cases. You can either pull out two socks of the same kind in just two tries, or you may take three tries. But then the thing is that once you pull out three, and if you don't have a matching pair, one will be pink, green, and red. Then the next one will always no matter which color, will always form a pair.
Correct. So how many socks must you take?
4.
You are correct. Well done. Good job, Zane, Zach, YN, Jaros, Elias, Isaiah, Kyler. You got it correct. So students, if you want to visualize how this problem looks like, we write down the colors: pink, green, red. So you start picking out your socks. Let's say you took a pink, and then you take another pink. Oh, very good. You are very happy. You just need to take two, and then you have a matching pair. However, if you give me the answer two, what if you take two socks, pink and one green? Is that enough? Will you have a matching pair? No. So you must always assume that you will end up with the worst case scenario. Okay, so you must always pretend that it is going to be the worst case scenario. You're not that lucky. You're not going to take two socks immediately with the same color. So just pretend that you're very unlucky. What is the worst thing that can happen? That you take all the different colors, right? So let's say you took three socks. All of them are different colors. Do you have a matching pair? No. So if you don't have a matching pair, you must continue taking. So let's just take one more. Does it matter which color you take? It can be pink, it can be green, it can be red. You will always have a matching pair. So the answer is 4. As long as you take 4, right, you will definitely have two colors that are the same because there's only 3 different colors. Yes, Zane, question.
Wanted to say that I want to say I had to think about it because first I tried to do probability.
Oh, no, 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 no need to do probability. Okay, it's more of logic. It's just telling yourself that you're very unlucky, and what must you do? How many socks must you take? So, students, can I modify the question now? Now, instead of asking you how many socks must you take to get the same color, to get a matching pair, I'm going to ask you another question. Okay? I'm going to ask you how many must I take to have at least 3 of the same color? Students, if I change the question like that, do you think you can still logify it? Come, I give you 2 minutes. Let's try this. Your time starts now. Sorry. I've I made a mistake. At least 3. I'm not supposed to say of the same color. I'm supposed to say of each color. That means I want to have 3 pink, I want to have 3 green, and I also want to have 3 red. So I want to have 3, at least 3 of each. of the colors. That's what I want. Okay, can you type your answer in the chat, please? Okay, so let me ask Kaizet, okay? Kaizet, we have 3 different colors. Pink, green, red, right? So you want to have 3 of each color. So let's say I took 3 pink. 1, 2, 3. Am I happy? Are you happy with getting 3 of pink? Do you need more pink?
No.
No, right? You want to go to green, right?
No.
So you go 1, 2, 3. Are you happy? Yes, you're very happy. You move on to red. 1, 2, 3. So total, how many socks do you take? Sorry?
9.
9. So if your answer is 9, what if the worst case happens to you? What if you take 9 and all of them are all pink? Will you have 3 of each color or not? Yes or no? No. So is 9 the answer?
No.
Definitely not. So let's go ahead. Let's say we took 3 pink. Would you like to move on to the next color? Yes or no?
Yes.
But are you that lucky?
No.
The worst thing will happen, which means that you will continue taking what you don't. Yeah, you continue taking pink. You taking the things that you don't want. That is the worst thing that can happen. So you end up taking all the 13 pink socks, right? Then after that, you move on to the green. You got one, because now there's no more pink, right? So you continue taking green. You have 3 green. You're happy. Do you want to move to the next color or not?
Yes.
But will that happen in the worst case? Nah, you will continue wasting your time to take all the
33.
33 green. And then finally, there's no more pink, there's no more green. And finally, you can take 3 red. And then you stop there. So in the end, how many socks do you take altogether?
49.
Correct. 49. Thank you, Kaizet. Well done. So students, can you see that you must always ask yourself, what is the worst case scenario? What is the worst that can happen to you? Yes, Aiden, question.
But can't you take like 12 red socks, 13 pink, and just 3 green? That is
Can.
because your question says the least.
Can. Very good, Aiden. Let's try what Aiden says. Pink, green, red. So he take 12, he take 13, and he take 3. So your answer will be 28 socks. Very good. You take 28 socks, right? Can you take 28, huh? Let me tell you what will happen to you. This is what will happen to you. You only have all green. Understand? So you must take into account which socks has the most number. Which color have the most number? 33 green. What is the worst thing that can happen to you? You took all the 33 green. Then which is the next biggest number? The next biggest number is 13. Then you end up taking all the 13 pink. Yes, Zane.
Basically, for this one question, when they say least, is that asking you for like the most?
At least, actually. At least.
I know, but it's kind of like it's asking you for the most. So basically, for this one, you must try. You must use the highest values, right?
Yes, you must use the highest values. You are correct. Yes, Aiden.
So is there only one answer or
It's only one answer.
is
The answer is 49. The answer is 49. Because if you give me 28, you will fail. You give me the answer.
At least one is in real. If this is real life scenario, then
It
that's
can happen
maybe the
also.
answer.
No, it can happen also in real life. Like if you really take 49, then I can guarantee you that you will definitely have at least 3 of each color. Yeah, you will have at least 3 of each color. So students, if you take 28, right? In real life, you can take all green, what? Then you will not have 3 of each color. You'll fail. You'll fail. You understand? Yes, Isaiah?
Since this is real life, right? Since you also work in real life, why don't you make someone Why don't you make someone do it in real life?
You can. If you do this experiment, and if you take 28, it might be possible for you to get all the 28 green. You understand?
What if I take my most unlucky friend ever and make him do that?
Yes. Yeah, Aiden?
But it's possible that you only take 9 tries to get all like
Yes. You can be very lucky. Yes. So basically, you can be very lucky. If you take 9 and you get 3 pink, 3 green, and 3 red, yes, you succeeded. But what is the question really asking for? They want you to guarantee that you must have at least 3 of each color. If you take 9, you are really taking a big risk. You are taking a big risk because there's a very good chance you will fail. There's a very good chance you'll fail. So, students, well done today. We have completed all the questions and we have applied quite a few different strategies here. So, what I want you to do, students, print out the worksheet, print out the blank worksheet, and redo the questions that you got wrong. Also, watch the lesson recording and look at the solutions. The solutions and the recording will be uploaded in the portal. So, please do your revision and you can strengthen your understanding, especially how to apply the different strategies. All right. So I will see you tomorrow for day 2. Well done, students. Bye, everyone. Bye, Isaiah, Aiden, Elias, Isabel, Isabella, Hanson, Jaros, Kyler, Kaizet, YN.